The question mark in the title of my lecture is significant because I shall raise more questions than I can answer. Let me assure you right away that I do not know all the answers, but I think I have some important questions to discuss with you. I do not intend to discuss what you read and hear about in the daily papers, the periodicals, countless speeches and sermons. I admit these are the all-important and most urgent issues confronting mankind today. With the help of science, that is of applied science, we are apt to ruin our planet as a place of living for mankind. We have not even begun to take seriously the warnings of natural and social scientists in regard to the spoiling, that is the various sorts of pollution, for instance, and of the danger of overpopulation, possibly standing room only, on the earth in about 100 years. I shall merely mention what terrible blunderers we are in the art of living together on this earth, individually, nationally, racially, and internationally. The zoologists classify us, human beings, as Homo sapiens, wise men. Aristotle, the great Greek philosopher, BC, defined man as the rational animal, but I have had my serious doubts about that. No doubt what he meant was that we have the capacity for rationality, but we don't exercise it very frequently. We are frightfully irrational, as a matter of fact, in the conduct of human affairs. Even with the very incomplete and uncertain scientific knowledge that we do possess, we could make life tremendously more healthy, more sane, just, peaceful, and perhaps even more happy. However, I shall not dwell any longer on these, I repeat, most urgent matters. As I understand the assignment of my lecture, and let me say I appreciate the honor of this occasion very deeply, I shall deal with matters which lie within the primary field of my own philosophical endeavors. In brief compass, I shall discuss the nature and the limitations, alleged or genuine as the case may be, of science and especially of scientific explanation. This requires that I first make a distinction between the pure and the applied sciences, which is fairly obvious and hardly requires elaboration. It is one thing to search for knowledge. It is one thing to try to attain the truth concerning matters of fact, the regularities of the universe, of human beings in the social context, as the social disciplines of the social sciences are trying to do. And it is another thing to utilize knowledge thus acquired for the sake of practical ends in human affairs. The distinction is a logical one, historically, actually, sociologically, and so on. Of course, the two are intertwined. There is a process of mutual fertilization, shall I say, going on between pure and applied science. There are many questions in pure science that arose out of the technologies, out of medicine, agriculture, and so on, social planning, education, and so on. These questions come back to pure research, and on the other hand, of course, there are countless examples that could be given where originally pure research has been applied toward practical ends. Now, what I wish to discuss are the alleged limitations, or the alleged and the real limitations of science, and this I will do only concerning pure science. The much asked question, will science save us? And actually a well-known sociologist quite a few years ago published a book, Can Science Save Us? And gave a tentatively affirmative answer to that. That question is ambiguous, because I think it should be clear from a logical point of view that no amount of scientific knowledge in the natural or the social disciplines by itself, the kind of knowledge acquired in the pure sciences, will be sufficient in order to put our affairs into a better state of harmony, of peace, of justice, and so on and so forth, the things that are so badly needed in our day. it seems to me that value judgments, although they can be studied scientifically and are being studied scientifically by psychologists, anthropologists, social scientists quite generally, look at the economists for instance, that evaluations themselves are not purely scientific, because science can serve only as a signpost. If this is what you want, then with such and such probabilities, if science knows what is relevant here, you will reach your end if you proceed thus and so. So pure science does not dictate, it does not by itself suggest ways of acting. This is a genuine limitation. Those who deplore it simply do not know what science, pure science, is all about. It would be like asking of a washing machine that after all is built for a certain purpose to make fine music. There are other instruments for that purpose. You see. The washing machine may be quite all right for its own purpose. Now, so here is a genuine limitation of science, but which we need not deplore, because if anyone considers it a limitation, he has misunderstood the task of pure science. What does pure science really try to do? Let's forget about mathematics, which would lead us too far afield. I mean, pure mathematics, important as mathematics is, also, of course, nearly everywhere today in the natural and social sciences. But if we talk of the factual or empirical sciences, I would say their major aims are describing of what there is, and explaining as best as we can what there is, and what there is of regularities in the world, of nature, of man, of society, and so on and so forth. So the first question that is so often asked in the newspapers and the periodicals and sermons and so on these days, aren't the scientists responsible for the misuse of scientific knowledge, as for instance in connection with nuclear energy, in war, in the implementation of aggressive activities, and so on and so forth? Well, the ones that are closest to these applications or misapplications are, of course, the ones that are engaged in applied science, the engineers, the technologists, and so on and so forth. It is not the pure scientist who looks for knowledge. I have to be brief, and you will please have to excuse that. So I may sound dogmatic, but these are the results of reflection of many decades of thinking. So I put it in this rather assertive manner, and since this is, fortunately, I understand, still a free country, you don't have to believe what I say, of course. On the other hand, I'm expected to be free in what I have to say. Now, since philosophy of science is my special field, or one of my major special fields of research, I should perhaps say a few words of how philosophers of science, or at least the majority of them, look at science. I think by and large the time is over when philosophers could help blaze a trail for new scientific developments. I don't exclude it. How does Shakespeare say? This is a wish whose consummation is devoutly to be desired. But if a philosopher operates from the traditional vantage point of the armchair, his armchair, he cannot possibly contribute to the advance of science if he's ignorant of science. He'd be a mighty lucky stiff if he could contribute an idea that turns out to be fruitful. So only philosophers who are conversant at least with some, or at least one basic science, can afford to philosophize responsibly about it. What is it then that we are trying to ask and answer in connection with this question of the nature and the limits of science? Well, it is the question, what are the tasks of science? What do we try to do in pure science? And are there any tasks that are impossible of fulfillment? Now, in regard to these questions, philosophers are perhaps to be compared to art critics who also operate by hindsight. That is, it is the artist, the musical composer, the painter, and so on, who produce the work of art. It is the critic who tries to understand and, if possible, to evaluate, to appraise it. The philosopher of science, in a sense, is a critic of this sort, but nowadays he's got to be pretty modest because, as most scientists feel, philosophers, please keep out, they almost put up a sign for that, reconstruction going on. Science is in constant turmoil and revolutionary change. I hope you don't mind a few radical words like revolution occasionally. Now, but philosophers differ in temperament, as already William James has pointed out, by way of an oversimplification of which William James, the great American psychologist and philosopher of some 70 years ago, was fully aware. He distinguished two basic temperaments, the tough-minded and the tender-minded. The tough-minded is the realistic attitude, which usually says nothing but. Man is nothing but a system of atoms in physical-chemical interaction. That's one view, you see. Concepts, just words, nothing but. Then there are the something more philosophers, the tender-minded, who see mysteries which perhaps aren't there, who project mysteries into the world. It's been nicely summarized, these two temperaments, in a conversation that I heard from Alfred North Whitehead, the great British philosopher who came to Harvard in the late 20s. And he's speaking of Bertrand Russell, his friend and great contemporary, great mathematician, or rather logician and philosopher. And he said, Bertie, speaking of Bertrand Russell, Bertie thinks I am muddle-headed, but I think Bertie is simple-minded. Here you have the story of philosophy in a nutshell. Nutshell is right. Between these two extremes, we've had all sorts of philosophies, you see. I have used this in a sort of dialectical scheme, not taking seriously at all what Hegel or Marx or Engels had to say about dialectics, thesis, antithesis, synthesis, I consider this merely a question of the zeitgeist, the spirit of the times, not a matter of logic at all. It's almost like fashions, long skirts, mini skirts, medium long skirts. The pendulum swings in different directions and finally settles somewhere in the middle. Now, and that way usually lies sanity, The young have to be rebellious, the old ones have to be reactionary, so somewhere, sanity is achieved between the two, and progress is still safeguarded. So I would like to plead, instead of a philosophy of the nothing but, full of reductive fallacies, like man is just a machine, nothing but like a machine, and the seductive fallacy, man is equipped with an immortal and indestructible soul. What's what philosophy, which is not so easily exemplified in this case, but I'll say a few words about that if time permits later on. So between the nothing but and the something more, I plead for the what's what. Not read mysteries into the world that aren't there, not reduce the world to an absurdity, but to look the facts straight in the eye, and while being courageous, bold in our conjectures, hypotheses, and theories in science, we should be equally critical in testing, in assessing them, both from the point of view of experience, observation, experiment, statistical design, and whatnot, as well as through logical critique. The dialectics manifests itself also in certain types of mentality that you might call the dogmatic on the something more side. Knowledge, especially scientific knowledge, is considered by some people to be something more than mere opinion. And by others, it is considered mere conjecture, mere opinion, nothing but a guess, possibly an educated one. Now perhaps here too we have something in between the dogmatic attitude of the tender-minded and the extremely skeptical attitude on the tough-minded side. And what is the golden mean here? the critical attitude, the attitude of the open mind. As I have to assure my students occasionally, even in regard to such questionable things as, let's say, ESP, extrasensory perception, not to mention worse things, I go at least through the motions of an open mind as an empiricist. You know, you have to admit there may, as Shakespeare also said, there may be more things in heaven and earth than we philosophers or scientists have dreamed of. Now, of course, the way you place your bets in regard to ongoing research and as to what is a fruitful avenue, this will always remain a more or less personal matter. Nevertheless, science cannot be as subjective as a current fashion makes it out to be. On this I will have to say something in a moment. Now, among the genuine limitations of science, if you want to call it limitations, but that's only the washing machine fallacy, you know. Science wasn't built for that. Then first, what I mentioned already, namely, we cannot, without further premises, which are not scientific or non-scientific, derive moral imperatives. Whether you get these moral imperatives from your religion, or whether you get them from a humanist outlook, as I prefer to do it, that's your private affair. But in any case, it helps, at least toward philosophical clarity, to realize that no amount of knowledge concerning human nature and human nature in the social context can tell us what is right and what is wrong by itself. Of course, whatever knowledge we have, and it is all only probable knowledge, will tell you what is likely to happen under what circumstances. That is the very meat of scientific information. Science, at its best and its most reliable, tells us what happens under what circumstances or which variables are correlated with other variables to what degree, with what correlation coefficient, as we put it technically in modern statistics. So science by itself can be, while of great help in the attainment of human goals, cannot by itself give us the direction. They must come from a basic moral, social, human commitment. And science, of course, in that connection can also not provide the sort of hope, edification, fortification, admonition, or consolation that the religions provide. Now, coming to the tasks of science, I'm inclined, speaking of the factual or empirical sciences, natural and social, I'm inclined to define them as description and explanation. Give an account of what there is and accounting for it, both for individual facts as well as for the regularities of the world. Are there any inherent limitations there? Now, many philosophers and even scientists have felt that there are unsurpassable limitations of scientific knowledge. A great German physiologist with a French name, Émile Dubois-Reymond, became famous last century in Germany and other parts of the world by two essays, actually original speeches that he made. One, I translate from the German as best as I can, about the limits of natural knowledge, and the other one about the riddles of the universe. And he concluded with his famous Latin phrase, ignoramus et ignorabimus. We do not know and we shall never know. And he listed, I think, 10 riddles of the universe. I don't have the list here, but I remember several of them. 4 of which I think he said might be solvable by the advancing research of the sciences. I think he was right, at least in one of them. We are beginning to have at least responsible hypotheses concerning the origin of organic life on Earth. That was one of his riddles of the universe. To be sure, we aren't sure about it, but we are beginning to have an idea that this could have come about quite naturally by chemical synthesis. under conditions which very likely prevailed a few billion years back. But then in his list of the riddles of the universe, he also mentioned such questions as the ultimate nature of force, of matter, the relation of mind or mental processes to the body or brain, the problem of free will and responsibility, and so on and so forth. Now here, in regard to these allegedly unsolvable problems, various attitudes have been taken. Ernst Haeckel, also in Germany, shortly after Du Bois-Reymond made his pronouncements, answered with a book, The Riddles of the Universe, and said they're all solved. Science has got the answer. But if you read that book, then you find that Haeckel, while by far not as sophisticated philosophically as his British counterpart, Thomas Henry Huxley, grandfather of Aldous and Julian, whom you may have read. If you haven't read The Old Man, Thomas Henry, still worthwhile. Thomas Henry Huxley maintained that science is just organized common sense, is an extension, a tremendous extension of common sense knowledge toward higher reliability, higher precision, higher cohesiveness or coherence, greater testability, and so on and so forth. So, one answer, call it tender-minded if you will, was the one, well, science has solved essentially these problems. If you want to know about the nature of matter, ask the chemists and the physicists and the physical chemists. If you want to know about the nature of force, why there are plenty of physical laws, such as the classical ones of Newton and Coulomb and more recent ones in nuclear physics. They tell you what forces are and how they act. What more could you possibly want to know? The mind-body problem is perhaps a different type of question. I have off and on in my life been much concerned with it. It's one of the major 5 or 6 hobbies in my own philosophical endeavors. On Mondays, Wednesdays, and Fridays, I think, well, maybe there is some hope and it will get cleared up before I die. And on other days, Tuesday, Thursday, Saturdays, I am somewhat doubtful, and perhaps there are some aspects of the problem which resist solution. But why? That is the question that many of us in intensive controversies are concerned with nowadays. Now, the school of thought that Professor Broadbeck was kind enough to refer to, the Vienna Circle of Logical Positivists, took the attitude, show me an unsolvable problem. Show me that it is unsolvable, and I'll show you that you've barked up the wrong tree, that you've asked the wrong question. So a whole school of thought, stemming partly from Vienna, partly from Berlin, partly from American pragmatism, particularly Charles Sanders Peirce, William James, John Dewey, and so on, converged toward an attitude, let's not ask foolish questions, questions which, upon logical clarification, reveal themselves as pseudo or phantom questions. Now, let me illustrate this just a little bit in connection with scientific explanation. Let me tell you first a funny story about that. There have been people so tough-minded that they said, scientific explanation, there is no such thing. Otto Neurath, one of the leading organizers and propagandists of the Vienna Circle philosophy, a great man in his own way, sociologist, economist, and so on, once invited me to write a monograph on scientific method for the International Encyclopedia of Unified Science. So I wrote back, I'm very flattered, very pleased. I think I will write about principles of scientific explanation. Came back a letter, special delivery, airmail from England. Herbert, don't you know any better? There is no such thing as scientific explanation. It's all description. As a matter of fact, the word explanation ought to be put on the index verborum prohibitorum, on the index of forbidden words. Let me explain, he continued. I had a good laugh myself when that happened. Anyway, I think even from the point of view of common language, in which so many philosophers, particularly after the work of Ludwig Wittgenstein and John L. Austin, are so much interested these days, even from the point of view of common speech, I say, there's a difference between giving an account of what you observe and accounting for what you observe. An intelligent 5-year-old can describe a rainbow, but may not have an idea as to how a rainbow comes about. It takes several laws of optics, at least those of reflection, refraction, dispersion, in order, and a lot of geometry, in order to account of how a rainbow comes about and why it appears in the place where it does appear, and so on and so forth. Now, throughout the history of human thought, there has been a deep-seated desire to explain the facts and regularities of the universe in such a fashion that the very premises used in such explanation, the very assumptions that we need for such explanations, must be self-evident. No doubt, the example of pure mathematics that so greatly impressed the Greek philosophers, Plato, for instance, Aristotle, was responsible for this view of the nature of scientific explanation. In pure mathematics, it was thought for many centuries, we start with self-evident premises called axioms. Take one of Euclid's. If two magnitudes are equal to a third one, then they're equal among each other. You might say, what could be more obvious? Now, and this is actually used in many proofs in geometry and in mathematics quite generally. But look at it a little more closely and see how this so-called eternal or absolute truth, and look how cheap it is. It is simply a consequence of what we mean by equality or identity. You wouldn't call any two things identical or any two descriptions as referring to the same thing if the Euclid axiom did not hold. In other words, what we in logic call the transitivity of identity or equality of any kind. Similarity is a different story that may be non-transitive. Now, so the ideal of pure mathematics has been extremely seductive. So for centuries and throughout the Middle Ages and into the rationalist philosophy of the modern age goes the ideal that a genuine scientific explanation must be such that ultimately we will understand the very premises, the fundamentals of scientific explanation in an a priori way, on the basis of pure reason. Intuition must be able to tell us that they are true. But the only truths that are self-evident are either the ones to which we got used. One of my favorite infamous sayings is, it is familiarity that breeds intuition, you know. Once you get thoroughly accustomed to a certain way of things, then you find it finally self-evident. It couldn't be any other way. But if you strain your imagination, you will find that there could be other ways. It ain't necessarily so. It's a very wise saying, you know, in empirical science. So we've had a number of basic patterns of thought in connection with explanation of the facts and regularities of the universe. For instance, one of them, which became outmoded at least in the last century, if not earlier, is the animistic one. Explain magnetism, magnetic attraction and repulsion, in analogy to human love and hatred. Well, that seemed to invite itself in ancient Greek times, but there isn't a single physicist today that would say this is at all enlightening. This is projecting something all too human, anthropomorphic, as we nowadays call it, into inorganic nature. It doesn't help at all. So modern theories of magnetism are very, very different. More about that in a moment. Then another thought pattern, which had a triumphant march of advance throughout the ages, is called the mechanistic one. Or as Alfred North Whitehead put it so prettily, it is the attention to the pushiness and pulliness of things. You know, even children get fascinated, especially children, get fascinated with anything that moves, that can be pulled or pushed and so on. That's the way children get their first orientation in the physical environment in which they have to live anyway. So the pushiness and pulliness of things was finally systematized by the great contribution, I'll mention only the greatest two names, there are many others, of Galileo and Newton in the 17th century, who gave us certain fundamental laws, or later called postulates, the laws of motion, the law of gravitation, Newton's great contribution, anticipated by others before, but anyhow, Newton put that all into a system and explained these concepts very clearly. Now, these two thought patterns, among many others, there were artistic thought patterns of explanation, comparing the universe to a work of art, the harmony of the spheres, still played upon by Kepler in his Harmonices Mundi, that the whole planetary system is like a musical instrument on which the angels make beautiful music, and so on. These did not help. Or the economic thought pattern that the universe is like a well-ordered household. It is a human frailty that explanation usually begins with analogies or models that we can hardly think without projecting onto the facts observed or behind them some sort of a configuration with which we are familiar, either animistic, that is from our own emotional life, like love and hatred, or mechanistic, pushiness and pulliness. Now, ever since the middle of the last century, I would say scientific explanation has proceeded in different directions. Scientific explanation is no longer necessarily familiarization, the reduction of the new, the weird, the unknown to the well-known, the totally accustomed, the familiar. With the beginning of electromagnetics in the last century, notably through the experimental research of Faraday and the theories of Clerk Maxwell in England, we have a science of electromagnetics which is mathematically highly abstract, but which nevertheless has great explanatory power. So we have changed our mind on what it is to give a scientific explanation. Not everybody is happy with this, because many still cling to the idea scientific explanation must be a reduction to the familiar, otherwise they are not satisfied. But the new ideal of scientific explanation simply consists in attempting, that is, explanation is to attempt to cover a maximum of observed facts by a minimum of basic concepts and principles. Never mind as to whether these basic concepts, assumptions, principles, presuppositions, whatever you call them, are familiar, self-evident or not. In modern physics, hardly any of them are self-evident or intuitively cogent. But they are fruitful. They are fertile in the sense that if you assume them, then by logical mathematical derivation, you can derive the empirical laws that tell you what happens under what conditions. So, if we understand that in the very nature of science, explanation, and science as conceived nowadays, explanation does not require self-evident premises, does not require absolute certainty, but is satisfied with premises, with assumptions that are fruitful in the derivation of a great number of facts, then science has gone a long way satisfying this sort of intellectual appetite. Now, of course, as the proverb has it, at least I know one in German, I'm not sure whether you have that in English, a fool can ask more questions than 10 wise men can answer. Well, some philosophers have been fools of that sort and continue to be. Take some existentialists like the German Heidegger of recent fame and great influence. He asks, in print, mind you, why is there anything at all? And why is what there is the way it is? Well, maybe I'm too flat-minded, but I refuse to understand these questions. If they were meant theologically, all right, theologians are able to give an answer. The world is the way it is because this was the will of God. But you're not supposed to ask any questions, why was this the will of God and how come God exists, That's forbidden. Martin Luther was whittling away on willow branches to make whips for those who ask such questions as what did God, what did God do before he created the world, and why on earth or any other place did he create the world? Luther said, you're not supposed to ask such questions, you see. So, take other mythologies. I think it's in Hindu mythology. The world, after all, has to be supported by something. I guess an architect would understand that the world has to stand on something. Buildings, after all, have to have a solid foundation. Or the Hindus could think of something. It's an elephant that carries the world. Then it occurred to some people to ask the question, and what does the elephant stand upon? And they said, oh, it's a giant tortoise, a turtle. Then apparently fatigue set in, and they didn't ask the question what the tortoise was standing on. So you can see we had to wean ourselves of asking questions of this kind. We had to become more modest. We had to lower our level of aspiration. So according to one philosophy to which I still adhere, these questions really have no cognitive significance. They are produced by language gone wild. Take some other example. We express ourselves metaphorically often enough. For instance, somebody wide awake might say, finally my sleepiness went away. Suppose you ask him, where did it go? So clearly, there are foolish questions that we can ask. So by an analysis of the conceptual frame of our knowledge claims, we can find out what makes sense, what kind of questions to ask, and what questions are not to be asked. Now, science, of course, has not reached any definitive conclusions, nor is it likely that it ever will in any field. Revolution, change is the order of the day, but it is not as chaotic as some journalists make it out to be. Some exaggerate and say the science of today denies everything that the science of yesterday maintained. Not so. Very frequently, consider for instance the progress made by Einstein and his relativity theory over against classical mechanics. We can find that at least as far as the quantitative aspects are concerned in the empirical phenomena studied, the new theories comprise the old ones as special cases. They still hold within a certain range of the relevant variables. You have to go up to some colossal speeds, way beyond those of the astronauts, in order to get the so-called Einsteinian or relativistic effects. So you have to distinguish between conceptual revolutions that, indeed, as in the case of Einstein, require a radical change of the conceptual frame, and the advance of science in regard to the empirical laws. I would stick out my neck and would maintain, I'm inclined to maintain, that while, of course, theories are the most interesting thing to the philosopher, high-level theories, like the Einsteinian, quantum mechanics, and so on, and physics, evolutionary theory in biology, the new genetics, the new molecular biology, and so on and so forth, depth psychologies, with some question marks. Now, while these are philosophically the most interesting things, the most stable knowledge we have, but not sure, not certain, but the most stable, the most reliable knowledge is in the empirical, the experimental laws that are ascertained by careful observation, measurement, experimentation, or statistical investigations. These are the ones. Theories come and go, and I'm not trying to be cynical, and I'm not trying to degrade theories. Theories can be enormously fruitful, but they should not be taken too seriously because indeed they change with new evidence as it crops up. Conclusion, science does have answers, but not to impossible questions. Science is an endless quest. So is the philosophy of science, so is philosophy in general. We shall never cease to ask questions. But if we are reasonable, we will be guided by logical analysis and clarification in asking questions for which at least there is some hope for an answer. And whatever answer we give in science or outside of it in philosophy should be held only until further notice. Thank you.